Hello all, for those of you that are just joining, welcome to Become a Kibana Search Expert. Some housekeeping items. We'll be taking questions at the end of the webinar. Please feel free to post any of those in the chat room throughout the presentation and we'll address them at the end. Additionally, we'll be sending out the recording at the end of the week so you can listen on demand. Hi, Zach, our presenter. Thanks for joining the webinar today.
Absolutely.
So before we get started, could you tell us a little bit about your role at Logz.io?
Absolutely. So, hey everyone, my name is Zach Hamilton. I'm a solutions engineer here at Logz.io. I'll also be your presenter today for Kibana Search Part 2. I like to give a little bit of background on myself because since you'll be listening to me speak for the remainder of the hour. I've been a solutions engineer for a couple of years. I started out my career at Oracle, working specifically with solutions centered around log analytics. I stumbled upon this cool company called Logz.io, and I've been here ever since. So I'll be taking you through the second part of Kibana Search 2 today. So jumping right into it, the first thing I like to identify is our Academy. Now, this is a resource that we've gone live with recently, and it's a great way to learn at your own pace and get exposed to things like tutorials, webinar recordings, ebooks, how-to guides, and more. Sometimes listening to an hour-long webinar can be a large commitment, so if you want to just be able to chip away at some self-paced learning, Logz.io is a great way to accomplish that. So I urge everyone, if you haven't seen Logz.io Academy yet, just go to academy.logz.io and you can see the cool resources there. Now, I want to give a brief agenda of what we're going to accomplish today. So our first goal is we're going to do some basic recap of what was covered in Kibana Search Part 1, just so that hopefully we can get everyone on the same page. It's understood that maybe you weren't able to go to Kibana Search Part 1 and you need to get up to speed really quickly, so we'll touch briefly on the concepts that were covered there. After that, I'm going to give a high-level introduction into the advanced search types and techniques that we're going to cover in today's session. And then what we're going to do is we're going to transition into some real-world application examples, actually looking at the Logz.io platform, interfacing with Kibana, and actually being able to make some searches on data itself. So moving right along, we'll get right into our recap. So as a beginning to what we covered in Kibana Search Part 1, we talked about the concept of data parsing. So I'm going to touch upon it again here. So as an introduction, what is data parsing? So data parsing in its simplest sense is just taking some kind of string of text or a document and extrapolating that into a field value pair combination. Now, we do this and we recommend that you do this in Logz.io because this is how data is stored natively in Elasticsearch, which is going to be the backend that Kibana consumes in order to give you the ability to search your data. Why do we want you to do this? And that's the reason that, you could totally store log lines as just single messages and you could search them actively with Kibana. But you sacrifice the ability to create visualizations, to have individual searches that you make on fields, and things of that nature. So how do we accomplish this? We use a JSON format. We recommend actually that logging is done in JSON format because this ensures that all parsed fields make it into Elasticsearch effectively. If any changes are made in those fields, it can be automatically picked up since Elasticsearch understands how to use the JSON format. You can obviously log into just plain text. Many technologies out there automatically are going to log in plain text. And we can still handle this and we'll do automatic parsing of common log types. For example, If you have something like an Apache access log, as you can imagine, this is going to be a log source that we understand how to parse into fields. If you want to see a list of supported log types, you can always find that on our log shipping page and throughout our platform. If you're going to send a unique log type, maybe you have a custom application log or something like that, we offer parsing as a service. We can apply the specific field value pairs that you've asked us to, and we will actually do that for you. And the channel that you'll contact in order to accomplish that is support. If you want to parse on your own, as you can see here on the right in the image, we also have a data parsing wizard that you can go through in order to accomplish this on your own. Now, to wrap up the recap of Kibana Search Part 1, we're just going to go over the basic search types that we covered. The first and most simple is going to be a free text search. It's less performant than other search methods, and the reason is that this casts a very wide net. As you can see here, we have an example search query. The quick brown fox jumps over the lazy dog. Now, as an explanation of why this is less performant than other search types, is simply that each one of these individual words is going to be searched as an individual search item. So therefore, a result that has one word and not necessarily all can still be resulted. So searching this string, we could get log lines that just have the in it and nothing else about foxes or lazy dogs. The next one, field level searching, is going to be significantly more performant and accurate. It's going to give you a tighter sense of control on what you're trying to do and trying to extract from your data. And this is something that we see our customers using a lot more actively than just free text search. For example, you can see here, we have the field fox and the field dog, and we're specifically looking for the value of quick and the value of lazy. This extracts that at a very, very specific level, and we get really into it, and we don't get log lines that just have the word the in it. Finally, we have filter-based searches. Filter-based searches are going to work very similarly to field level, except there is some functionality that you won't have, and we'll touch upon that when we get into the demonstration portion. Some of the most important things to know about filter-based searching is that it's going to be always additive. So for instance, as you can see in fox quick and dog lazy, if we were to add another filter-based search on top of that, it would also be an explicit and search operand, and therefore it would be additive and continuously filtered down. So now we're going to jump into what we're going to cover in today's session of part 2. There's going to be 5 key search types that are going to be considered advanced that we'll go into. The first category we're going to touch on is going to be wildcards and fuzziness. We're going to get into then proximity, how to use it, boosting, then range searches, and we'll do some regex at the end. So to introduce at a high level, wildcards and fuzziness, this is a type of search and a mechanism that most people commonly understand, since it makes its way into all kinds of different facets in text-based things with machines. We'll explain it again just so everyone, if you don't know, is on the same page. Essentially, wildcards can help you abstract a character or a string of characters that could be potentially variable. So in this case, in the example, the quick brown fox, we don't necessarily know that between I and K that there's going to be a C for quick. So since maybe a misspelling or something like that, it will still match quick if we put an X in there because someone accidentally clicked the X key. The asterisk operator is going to basically make variable the entire rest of the line. It can represent 0 or many characters. So we're essentially saying that we don't care what comes after fox because we're putting the asterisk there to just make variable the rest of the line. Proximity is going to be our second search type, and this one is probably a little, could potentially be a little bit less familiar with people. Essentially, all we're doing is we're trying to identify a distance between two terms that we want to extract. So you can see that we have lazy and fox, and we use the tilde operator and 5 in order to say that we don't know if it's lazy and then fox or fox then lazy, but we want them to be at least 5 tokens or words away from each other. This way, if we're trying to find these two terms in the same single log line, but we have some variability, we can still match them and extract that. Boosting is maybe the least familiar with most people. We typically, I haven't seen it been used too often, but there are some specific cases where it can become very valuable, and thus we'll touch upon it nonetheless. To introduce it, essentially all we're doing is we're giving a relevance ranking to specific terms or subqueries that we want to match upon. As you can see here, the literal string quick brown, we're going to denote that with a relevance ranking of 2, which is the lowest relevance ranking, and then fox or dog is going to have a relevance ranking of 4. So the only other thing to note on here is that anything 2 or greater will be continuously more relevant. So therefore 8 would be more relevant than 2 and 4. And 0 and 1 are subtractive. So anything 2 or greater is additive. As the number value increases, the relevance of that search item increases. And with 0 and 1, and if you apply those, that will actually detract from the relevance ranking of the results. Like I said, the next two are going to be ranges and regular expressions. Ranges, pretty much everyone understands ranges. What I'll make sure I touch upon is the use of date types, numeric types, and string types. Most people are very familiar with numeric types, so I want to make sure that everyone knows you can also do it with date and strings. Most likely you won't be using a range filter for dates, just because you have the timestamp is usually the only date that you'll have in a log event. And Kibana is going to allow you to just natively filter on the timestamp using the UI features themselves. If it's the case that you have dates that aren't necessarily representative of the exact timestamp of the event of that log line that you need to filter on, it's good to know that you can actually do a range on date. And as you can see here, it could be whatever the field is and then a specific date to another specific date. You can also do it with strings. So if you wanted to do A to Z, you could do that. Lastly is going to be regular expressions. We're hoping that there's at least some basic understanding of regular expressions. I'm not going to necessarily get into how to write them today, but I'm going to give a simple example of a way that you could use them in the platform that could be potentially valuable. If you are on the call and you consider yourself a regular expression aficionado, you might have tried to do them in the platform and notice that the results you get aren't exactly what you expect. That's going to be because Elastic has their own domain-specific regular expression library. So if you're an expert on regular expressions, it's definitely worth your time checking out the Elastic documentation on regular expressions, which is actually hyperlinked directly from the Kibana interface itself. Last thing to note about that is going to be that you denote a regular expression query with forward slashes. So as you can see here, foo would be our entire regular expression. Same with the quick brown fox below. So that's going to wrap up the high-level introduction of our advanced search types. And now what I'm going to do is I'm going to get into some real-world examples here. Here we go. Nope, now my Kibana's up. So hopefully everyone is familiar with the Kibana interface. If you went to Kibana search part 1, you've already seen this before. For those who might be listening in who weren't able to attend, I'll give a basic introduction to the interface just so you're familiar, and what I'm doing isn't super foreign, at least. The Kibana interface has a few key places that you want to be aware of. The first is, like I mentioned, this ability to change the time frame from the timestamps of the log events that are going to be pulled in the platform. We're actually going to do this to get started. I want to set this to 24 hours just so while we're searching and demonstrating these search queries that we're actually looking at a full complete data set and not just last 15 minutes. Next thing is going to see is you saw this histogram update. This is just going to be a simple count over time of what is being shown here in this document table. So essentially when you're creating your searches, these two components here and here, the histogram and the documents, are going to update to reflect what you're querying. You can expand these documents to see the other available fields, and you can add and remove them in order to see some more insight of what you're querying. For most of today, we'll probably just keep the timestamp and the message just because we're doing some simple things and we're going to work with some different types of logs. Lastly, you can see that these are all of your available fields, and you can add them actively with very little challenge at all. So to get started, the first thing I want to give an example of is a filter-based search. And I'm going to start here just because it's my approach to looking for information in my log data. I like to filter by type first. So what I'm going to do today is I'm going to actually do a type filter, and you can see here that I can take my field name. The field I want to filter on is type. I can choose an operator. In this case, I'm going to say is, and I want to look at AWS Elastic Load Balancer logs. So I can pick the value, which is ELB for that, and then save that. We'll see my interface update, and we can see that now pretty much I'm only looking at Elastic Load Balancer logs. I'm going to use Elastic Load Balancer logs just to demonstrate some of these search queries in terms of wildcarding and other things like that. So I choose these logs specifically because a common case for wildcarding or fuzziness is going to be things like misspellings. If you're trying to grab all of your production logs or something like that, your production load balancer in this case, as you can see here, but someone's fat fingered a character and now all of these logs are coming in. If you search directly for production, all of a sudden you're not going to get some of the results back. So you want to use wildcarding in order to capture pretty much everything. Notice here that that's actually the case we have here, this field load balancer. So the specific load balancer from these ELB logs, someone spelled production site LB, producation site LB. So essentially if I filter based on production site LB for the specific name, I'm not going to get all the logs that were printed in with this misspelling. So an example how I could capture this nonetheless and get both is I could type in load balancer as a field-based search, and then just write prod star. So as we discussed when we were discussing wildcards, the asterisk is going to basically say everything after prod can be completely variable, and I want to capture it all. Since both production and production both start with prod, this means that it will capture both. So I search this, we can see now I still have production in here. So I've been able to capture everything. Now if I wanted to create a visualization based on these results, it's not missing half my data set or something like that. I could go a little bit farther and I could say site LB. So notice that now it's saying this is only variable from prod up to this next part of my search query. If I get a little bit more specific, we can see that the results really haven't changed. If we identify the number of hits here, they're pretty much the same as if I search it this way. So those search queries are identical in terms of results. LB. Now to use the other operand for wildcards, I could actually do prod you that. So I can use provocation and I can put a question mark over that character if I know exactly what the potential misspelling is. Searching this again, we can see that my results are identical too. So these are a few ways that you can use these two wildcard operators in order to abstract misspellings and still get the same data. My own personal favorite way to catch misspellings is actually using the fuzziness operator, which I'll introduce. So my expectation is that my load balancer is called production site LB. And I want to make sure that that's what I'm searching on because that's my expectation. But I want to make sure that I'm catching any misspellings. But in this case, I don't necessarily know that it's provocation, and it could be someone missed the R in prod or something like that. So I can use the tilde and I can type a number. And this is basically the fuzziness operator you can see here. Now searching that, it should still contain the same exact search results. And it's actually catching that misspelling again. Essentially what the fuzziness operator is going to do is it's going to define a specific edit distance between the term that you're searching and the terms it's trying to match against. Since I defined an edit distance of 1 here with tilde 1, and that this is an edit distance away from production of 1, it will still capture it. As I increase this number, I'm going to increase the amount of variability that I'm going to be tolerant to, and I'm going to catch more errors. So that's wildcards and that's fuzziness. Great ways to catch spelling errors or things like that. I'm going to move on now to proximity and show how we can use proximity. So I'm going to look at some Apache access logs now. So I want to disable my filter for ELB logs, and I'm going to add another filter specifically for a new type is Apache access. Cool. So now we can look at some Apache access logs. There we go. So let's imagine that we want to see if there's any that I want to look specifically at, like the request field or something like that. So we can see in terms of request. I can use a Kibana feature here. Oops, mistake. Actually, I'm gonna do it. I'm gonna pin this through. Let's change the idea here. Let's imagine that I'm looking for database errors. That's a better one. So to get started at a high level, I'm going to look for database errors. So imagine that I type in error and database. Now, like I imagine I explained the first time, this is going to be an example of a free text search. So I'm searching on these two queries here. So basically in Kibana, this is going to represent basically an implicit OR. So as you can see here, if I type OR in between these two terms, it's going to search and get the exact same results. So as you can see here, they haven't changed, right? So this is casting a very, very wide net. So I can look at some of my results here and I can see, looking into the log lines itself, I can go to the table view and we can see here that it only captured error. You'll notice that database was not captured here. And that's the example of this implicit OR. So I'm still trying to find error and database in the same line because I'm trying to extract database errors. So maybe what I want to do is try and search this as a literal line of text. As expected, I might not exactly have this present in all of my logs. So searching error in database has now been too specific. I transitioned from searching in a very broad way, error in database, and now I'm in a very finite way of looking for exactly a literal string. So I still want to get these on the same log message. So how could I do that? And that's where I could introduce the proximity operator. So tilde 5, or like you can see here, is basically going to say, I want to find these two terms in the same log line within a distance of 5 from each other. So I can search this, and you can see our results here. Now, rather than just get error or just database, I've now seen error and database. And we can see that they do actually exist in the same actual log lines. And before we just searched error database, it didn't match. Now, to identify what this does as an operand, you can see here that we matched twice in the same log line. So essentially, it's looking for anything that is any occurrence of error that is at least 5 words from the word database, and that matched twice here. Now we can actually demonstrate that you can change this, and the first error will actually disappear, right? So now, since this error is actually 2 words away, and I only specified 1, only this case of error will match that database. So you can see this working in real time. So I put it back to 2, this error will show up again. So this proximity operator is a great way to, if you're kind of sure what 2 words you're looking for in your log line, but you don't know what order they're in or how far they are from each other, but you still want to capture them, this is a great way to accomplish that, and you can get some quick search results. Then you can look at the lines that you're looking at and start to drill in from there. Now, the next thing that I want to talk about is boosting. And like I said before, it's a little bit more abstract of a concept, but still we'll demonstrate it here in order to show how it works. So with the same type of idea that we're looking at before, we're going to look for database errors. So I definitely want the word database to be present. So I'll do the caret and I'll do 8 to basically give that the most significant relevance in what is going to be returned to me in a search result. Looking at the errors I got before from the proximity operator, I actually think that exception will be a little bit more valuable to search rather than error, just because I didn't see very great results for error or whatnot, and I think exceptions will be more valuable. And then I still want to capture where it says error, so I give that a relevance of 2 and I continue. So now what I can do is, this is an example of just a boosting search, and I can get all these results, and I can see things like an error was triggered, so this matches only on error. We can see that this was triggered and it found exception, and so on and so forth. So this is an example of boosting, like I mentioned before, not seen as often, but it's still good to note if you have a specific case where you want to be able to rank relevance in specific terms. You can get sophisticated with these. You can attach it to any query, like we could say, do a regex pattern actually, and then search against that, or so on and so forth. So you can use that if you have a good use case for that, and it can be valuable there. So moving on, we're going to talk about the range search type. Now, most people understand ranges, and we're going to get into a specific example that shows a pretty common way of using a range search. We actually use it here at Logz.io pretty often, and for that, we're going to look at Apache access logs. So most people are familiar with access logs. They've got a lot of high-level information about events of hitting a web server, one including the actual response code. So as you can imagine, the response code in most cases is going to be heavily weighted to level 200 responses, and we can actually look at that. And I'm actually going to add this as a field. So you can see down there for each document, we have now also the response. If we look at the distribution of the response codes, it's exactly what we're expecting, with 94% of all responses are response level 200. So I don't necessarily want to look at activity that's error level 2 or response level 200. I want to see errors. So I want to see my 400 and my 500 level responses. So this is where I'm going to use the range search type in order to accomplish this. I can type in the field of response, and then I can use brackets in order to specify that I only want 400, 2, and 2 has to be capitalized. It's important to note. And then I can do the end brackets. Now searching on this, we can see that our values are going to change, and now we've omitted essentially from our search results all of the 200 responses. This is leaving us just with the occurrences of errors, either client or server side, that are happening, and we can look into this and we can start extracting more data from them. Ranges, pretty easy to understand. The only extra thing that's important to note is that you can actually use curly brackets or regular brackets interchangeably, and that will actually change the search function a little bit. In its simplest form, you can think of the difference between regular brackets and curly brackets as the difference from less than or equal to less than, or greater than and equal to greater than. And I'll try and exemplify that right here. So let's say I do 500 to 599, and I search that. We can see that we've only got 500 and 504. If I were to change this bracket to a curly bracket, it's now saying only, it's basically going to omit 500 from that result. And we can see that here because it's no longer an equal to operator. And we can see as I search that again, now 500 is gone. It's still defined in our range, but since we're saying that's the bottom of the range, we're basically starting from 501. And you can do this in any direction. So you could do that with the higher range as well. The next thing to note is that you can use other search mechanisms, like you can use an asterisk in order to just identify a ceiling or a floor that you don't necessarily know where it's starting or ending. So I can say 500 up, my search results haven't changed, or I could say 599 and then down with the asterisk. So basically all, and you can see that all our results, including the 200s, will show up again because it's saying setting the floor as completely open. So that's the range operator. An example of doing this is searching for specifically error codes or response codes so that you can make a specific dashboard or a visualizations only with response codes of a certain type. That's something we do here pretty often, and it's a popular demonstration of the use of a range. Now, what I'm going to do is I'm going to delete this, and we're going to give an example of a simple regular expression. So I'm going to unpin both these filters. So I'm going to write a regular expression, and bear with me here because I'm no regular expression expert, but I'm going to write a regular expression just to capture IP addresses in our message fields. So I'm going to type the message field, colon, and then as we remember from before when I explained at a high level how we do regular expressions in Kibana, I'm going to type a / to start the expression itself. Now I want to capture numbers 0 to 9. I want to do 1 to 3 of those, and then followed by a period. But really quickly, I'm just going to copy paste this. I'm going to paste period to then capture my IP addresses right there. So now searching this, we can see that we've got all our IPs show up. Awesome. So we successfully wrote a regular expression to do this. Now you might notice that some of the behavior here is not as expected. Like whatever this is like a version number, and those still populated. So you might wonder, okay, why did that happen in that regular expression? This is a common gotcha in Kibana searching with regular expressions. If you're getting results of something that you weren't expecting, you definitely want to double check to make sure that you don't have a reserved character or something like that you tried to search on. So that's essentially what we did. Since the period is a wildcard character, we actually have to escape those in order to get just IP addresses. So it thinks of it as a literal period and not a wildcard character. And then searching that again, you can see that we've only gotten IP addresses and we don't have, version numbers or anything like that. So this is a way that you could use regular expressions. Now, hypothetically, you'd want to take something like an IP address and you'd want to parse that into a field, just because that would be a pretty labor-intensive task to write a regular expression every time that you wanted to extract an IP address. It would be a lot easier, and it would allow you to create visualizations or to actually slice and dice your data on specific IP addresses and things like that if you parse it out. So something we like to state is that if you find yourself very commonly writing like very bulky regular expressions in order to identify specific pieces of data, it might be time to take a step back and think about ways that you could parse that data out and therefore just solve the problem once and then have a field for it. This is something that support can help at any given time if you want, and you want to extract that field from your data, and we can do that. So getting into an example of another regular expression we can write that might make a little bit more sense for a day-to-day. And what we do is just simply we're going to write a regular expression on the request field. So I'm going to actually put our Apache access logs back on here so we can just get the request. As you can see here, we have the request path. Let's say I'm going to pin this so we can see it. So the results are really just kind of jump off the page. I'm going to delete these two real quick. So we can see that we got all kinds of, let's say we wanted to search and visualize against all of our searches. I could use a regular expression in order to extract all of this. So I could say where request, and then start my regular expression. I need to escape that /, and then I can write search to escape the next /. There is a question mark after that /. I'm going to wildcard that, and then I'm going to just give the rest of the line as a variable. And then I can search this, and you can see that we'll be able to get all of our searches. Now I could do something, if it was useful to me, I could then say like, where's my request field? Oh, it's up here. I could look at the distribution of different endpoints that searches are being made for, or different words, or I could even visualize this and start to see some of this this data and start to come up with some insights from that. So at a high level, that's a way you can use regular expressions. Now, that's all that we were planning on covering for today in terms of the hands-on portion of it. So I'm going to transition right back to our slide deck here just for some last minute items and some Q&A. So before we jump back into Q&A, the next steps that we want to prescribe is definitely taking a look at things like our blog, our free trial, and our academy. If you want to continue your learning with Kibana or anything like that, the academy is going to be a really, really great place to start. If you want to be hands-on specifically and not just watch videos, you can actually pair the two together and use the academy in a free trial. And then you can really learn hands-on with a set of resources that allow you to move at your own pace. All of these things are things that are going to be very simple and learn at your own pace and are going to be valuable to work with. So with that, we're going to transition into some Q&A here. So we're going to collect some questions.
Great. Thank you so much, Zach. It's a very in-depth overview, and I think it was helpful for a lot of our attendees. So we have a couple of questions. Let's kick it off with, so someone says, this is great for when I know what I'm looking for, but what if I don't know what I'm looking for?
Yeah, that's a great point. So as you can imagine, there's a huge bulk of data in that Kibana Discover view, and it can be daunting to just dive right into it. I mean, where do I even know to begin a search? My method of doing it is sometimes I go from a search that I try and make a visualization off of, or maybe I even do the reverse. Like I go and I look at my distribution of 500 responses or something like that over time in order to actually pinpoint other pieces of data that I'd want to go from. So in short, sometimes it makes a lot of sense to actually create a visualization off some high-level data. and then you can use that visualization in order to drill into something that you want to search on.
Great. Okay, next question. Can I search for the existence of fields that have similar names? For example, my field names are field_1, field_2, field_3. Is there a way to say search for all logs with the field underscore? It's a little bit of a long one, so give us a minute.
You should be able to, yes. So there's some operators that you can add onto a field with things like exists or other operators in order to make sure that your queries are looking specifically into that. That's something that is going to be a little bit more of a rabbit hole than something we would cover in a webinar like this, but it's definitely something you can find in the Elastic documentation. It totally makes sense what you're looking for, though. I would look into that. You can look into exists and things like that in order to figure out and search for all field names at some kind of variable.
Cool. Okay, last question. Oh, sorry, everyone, we have to wrap it up just for the matter of time. Okay, can you give an example of using the white space character?
Yeah, so that's a great question. So I'm assuming that this is in response to regular expressions as well. So yeah, so imagine you're trying to match on something that has just white space. That could be a space, tab, you name it, return carriage. So little bit of a loaded question in the sense that Kibana and Elasticsearch are going to handle fields and how they do the parsing a little bit differently. So this introduces the concept of like an analyzed field. Since everything gets tokenized by default, a delimiter of individual tokens is a space, and sometimes those things get omitted essentially because you've just created individual tokens rather than space characters being even present. Pretty much all parsed fields by default are going to be analyzed fields, but something like the message will be a non-analyzed field that you can have white space characters still present in. This is definitely something that makes sense to look at the Elastic documentation for, just because the regular white space character \s isn't one that's part of the domain specific regular expression library from Elastic. So you want to look into their documentation, and they have some ways you can do workarounds and things like that.
Okay, great. And the last question's a softball. It's for me. So someone's wondering if we'll be passing on the slides and video. Yes, we will be sending those in an email by the end of the week. Thank you so much again, Zach. That was really great. I think we've got a group of experts in Kibana search now. Okay, and again, thank you everyone for joining the webinar. Feel free to send any follow-up questions to us, and we're happy to reply. Make sure to join us for our next webinar. That'll be on August 28th. Then we'll be discussing containers, orchestration, monitoring, and logging. Okay, great. Everybody have a good day.